working with early stage entrepreneurs, developing their product. So that's the big picture. Today we are 42 engineers, and we had a pretty good growth in 3 years with more than 5 million turnover last year, and that's important because it allowed us to invest in research, and we invested more than 3 man-years last year on research and development, mainly about natural language processing technologies. So that's what we are going to share with you today, and that's our thesis. Okay, so after this quick introduction, first, what is the topic of today? We will share some insights about question answering. So I don't know if everyone is familiar with this NLP task. I'll just remind it very quickly. So question answering is the principle of asking a question to a piece of text to extract some information. So here you can see, and all our work is about French question answering. So the examples you will see are in French. So here we have an article from Wikipedia about the Suez Canal, and we ask a question about the opening year of this Suez Canal. And the goal of the question answering is to select the right answer. This example is on a very generic topic, but we can apply it to any sector, any industry. So here, for example, on the legal industry, and that's what Doctrine does. If we take an article from Legifrance, which is which details some elements about the law and work law, we can ask a question about this text. And the goal of the model is to extract the answer. All the examples you can see here is the result of our model. So we developed since maybe last summer a model that does question answering in French. Sorry. So I'll skip the examples. It's basically some examples on different sectors. So in industry we can do this, in the health sector on some health documents, and on banking, for example. And here HR on the resume. So this technology question answering is I'll show this just for a second. This is very mature for English language. You probably know FQuAD, which is the main data set for question answering in English language. And the last version of FQuAD has been released 2 years ago. So it's quite mature for English. But for French, nothing has been done before the work we released this year. Nothing had been done on question answering. So here what you can see is an extract from Papers with Code, which is a website that lists all the publications. All the points you can see here on the slide are one point is one publication. So between 2016 and today, there are a lot of publications on English question answering. But on French, that's the only point you can get, and that's our work of this year. So the main motivation of releasing such a work is that nothing had been done in French. And during our works with our customers, we realized that this was very important in various NLP tasks and various NLP projects to have some question answering to strengthen the approaches we could implement on NLP. The second motivation to release such a work is the release at the end of last year of CamemBERT. You probably had and I think you had a meetup on this topic with the FAIR team, the Facebook team. But nowadays the state-of-the-art NLP approach to develop NLP solutions is transfer learning. So we have a language model, and then we train downstream tasks such as question answering or summarization or document classification. And we train from this language model some downstream tasks. So we are highly dependent on the availability of some language models for French. And the fact that CamemBERT has been released at the end of last year unlocked and speeded up the works we were doing. So that's the two main triggers of the publication we will explain today.
So hi everybody, I'm very happy to be here today. So I'm Martin, so also a data scientist at ILLUIN Technology working with Wacim. and we have been working in close collaboration on the paper we're going to present today. So this part will focus on how we collected the data sets and how we trained the models and what kind of results we were able to get on the benchmark. So let's first start then with the collection procedure. Next slide. Yes. So the idea was to build a data set that would be very similar to its brother, to its English brother called FQuAD. So most of you must have heard about FQuAD. And FQuAD has a special format and was built in a specific way. So the way it was built, they collected good quality referenced Wikipedia articles, and so did we. So we collected so those good quality articles in French, covering many topics such as historical, technical, political, etc. So among them, you will find articles from l'Antarctique about astronomy with moons, like Ceres, but also more specific stuff like urban articles about Rotterdam and other towns. And so what we did is for each article, we collected some paragraphs that were not too short, neither too long, and then we had to annotate them. So for each paragraph, we would present them to an annotator and ask him to ask a question and then answer the question. So that's the first task, which is like thinking and creating new questions. And then the second task, we use also human annotators to present them the questions that were already built, and we ask them to answer. And we process those questions multiple times, so we can build a validation set and a test set, such that we can evaluate the performances of the benchmark in terms of human score, exactly like they did with FQuAD. So what we get in the end, so we get 3 sets. So a training set with more than 50,000 questions, and development and a test set with more than 5,000 questions on several hundreds of articles for the training set, and 30 and respectively 25 articles on the development set and the test set. And here you can see, so on the right side, you can see a screenshot we did of our annotation platform. So this is all done by the developers at ILLUIN that built an annotation platform specifically to source this data set. And what you can see on the left is also interesting. So we listed in the paper some question answering data sets, and you realize that you have a lot of different kind of data sets in English, but you have relatively few resources available in other languages than English. So here you can see Korean, you have a FQuAD, you have a Russian FQuAD, and now you have FQuAD, so in French. And note also that there is also another ongoing initiative with BIAF that have been collected also some samples. So that's it for the dataset, and we'll explain later how you can download it if you want to also enjoy training models on the datasets. So the training paradigm, basically how that works. Fortunately, in November last year, the guys from Facebook and ILLUIN, they released the CamemBERT model that you must have heard about. So which is a BERT-like model trained on hundreds of gigabytes of French data, and we use that model to fine-tune a question answering model on our datasets. And so how it works is basically you train the model by giving him a question, a context, and then you ask him to answer, and you then evaluate the model using 2 metrics. So we'll present the scores. Maybe most of you are familiar with the usual question answering scores like exact match and F1 score. But just to be sure everyone follows, we just recall what they actually mean. So first you have the F1 score, which computes the coverage of the true ground truth answer versus the model prediction. And you have the exact match, which is a bit more restrictive. So if you match exactly the ground truth, then your exact match score will be 1. If you don't, it will be 0. So next slide. So here you can see if you ask the questions quand est né Napoléon. So the answer, the ground truth is le 15 août 1769. You can see that the exact match, if you answer août 1769, then exact match is 0. And since you have like 2 right words in the prediction, then you have a F1 score of 0.5. So that's basically how you evaluate the performance of a question answering model in our case. So here are some results. So what we did, we had we have set up a very strict training process, and all the models, all the results we show, they have been performed using all the same hyperparameters. So they are described in the paper. If you want to try it yourself, you can, using the Hugging Face repository. So and they are described. I'm not going to cover what kind of hyperparameters we've been using, but here I can show you the results. And you can see that using CamemBERT large model, which was released first, so the human performances. Interestingly, you can see that F1 score of 91.2% is actually close to what they get on FQuAD, and we have an exact match, so which is a bit lower than the one on FQuAD, which is above 80, but we get human performances of 75.9% on our test set. And you can see that we have the native French models like CamemBERT and FQuAD give interesting performances, and you can see that CamemBERT base and large give respectively scores of 78 and 82%, which is quite good for first shot. And we can see that FQuAD performs a bit not that well, and we actually don't know why. So we are also happy to present those results today, because it could be an error from our side. So if anyone produces the results and finds best scores, just drop us an email. We'd be very interested. And also a big focus of our paper was to train multilingual models, because as you know, maybe, so the multilingual models are becoming quite popular. So in the zero cross training setup, so training and we'll present scores on that. So training a model on an English dataset and see how it performs on a French dataset is becoming increasingly popular and very attractive in terms of industrial applications. And here you can see that XLMR large and base perform actually quite well on the dataset when they are trained on French data. So,
just a focus on the human performance, because it could seem quite surprising that the human performance on such a task is not 100%. Just to explain you how we calculate it and how FQuAD calculates it. The thing is that, so we take the development set or the test set, and we ask the question to 3 annotators, and we check how these 3 annotators agree on the answer. And as we saw just before on the example on the date, we might, if we are 67 here in the call, if we have the same question to answer, we might not be on the same page on the tokens we highlight to get the answer. We might not be on the same answer. And we measured that on 5,000 questions, the average percentage of agreement between 3 annotators were 91.2.
Okay, so that's so that was for the evaluation on the FQuAD 1.1 test set. And here, what we present is basically the multilingual benchmark that is very interesting, because there we explore 2 different approaches. So the first approach is to evaluate how a monolingual model like CamemBERT will perform when it is trained on synthetic data, like translating the FQuAD dataset from English and translating into French, which is something that has been done quite a lot. And namely in Spanish. It has been done. And here it's interesting, since we have the native benchmarks, it's interesting to try that kind of experiments. And second, what we wanted to explore is what happens if we use a multilingual model that we train in English, and then we evaluate it on in French to see if the zero-shot learning setup works well from English to French. So the first results here show for CamemBERT large. Interestingly, you can see that when you compare the results in terms of F1 score, you can see that you lose about 3%, a bit more, when you do not train the model on native samples, but on translated samples. And you lose way more in terms of exact match because you drop from 82% to 74. So which is actually quite a lot. It can be enough for some applications, but if your application requires some performances, you will want to train your model on native data. And so we ask ourselves, okay, can we do better if we combine the data sets? So what happens if we take the French native samples we have collected on FQuAD, and on top of that, we add the translated sample from FQuAD and retrain the model. And it's interesting to see that we do not get a higher score. Actually, it's a bit lower. Might be due to a seed initialization, because that's a once example, once training. But the results are not better. So that's interesting too. So which would mean that samples, translated samples, do not bring more variety in that case. And then on the second kind of experiments with the multilanguage models, so what we see is that when we train the multilingual model on FQuAD, so on the last line, and we evaluate it on the development set of FQuAD, what we observe is that we lose about 3% in terms of F1 score, and we lose 5% only, 5.7% only in terms of exact match. So which is not a lot, and it also shows, interestingly, that those results are comparable to the results you would obtain with translated samples. They are quite similar. And but more interesting is if we do the same but reverse. So meaning we take the multilingual model, we train it on FQuAD, and we evaluate it on FQuAD, we get actually more interesting results, because we observe a drop in terms of F1 of only 1.9% and 3.9% in terms of exact match. So those results are interesting, because it means also that if you don't have, for your industrial applications, if you don't have native French samples, actually using multilanguage models can be appealing for many industrial applications. So that's an interesting conclusion. One next step we would like to eventually try would be to combine also FQuAD and FQuAD on the multilingual model, and see if we can eventually beat the reported scores. So, but that's left for further work. Finally, you will be able to use the models. If you're familiar with Hugging Face, you can download and use the models. We also built a leaderboard similar to FQuAD that you can see on the right. Those models we report in the paper, they can be beaten, because we haven't done any hyperparameter search, and we welcome any initiative to trying to improve the score on the leaderboard. If you want to evaluate your model on our test set, we are currently working on a way to do it in an automatic way. But for now, if you load your model into Hugging Face or you send it to us, we'll be able to evaluate it all by ourselves, because we do not release the test set similarly to FQuAD. And Wacim, anything to add on the resources?
No, I think you've mentioned the most of it. Maybe we wanted just to show you a demonstration of how the model could perform. Because so we built a demonstration. You can go on this link and try. So upload your context, ask your question, and see how the model performs. I think if you go all the 60 of you on the platform at the same time, it might not work. It's not built. It's not yet industrialized. So it's just a showcase. But we registered a small video. So we tried here to use a context which is a medical prescription. So this is a medical report of some either doctor consultations or prescriptions, and the goal is to extract some information from this data. So if we ask the model why the kinesiotherapy sessions were prescribed, the model answers cervicalgie fonctionnelle, sorry, which is quite the right answer here. And we try to ask the model different questions to see how the information can be extracted. So what type of patch this information is correct and is given at the end of the text. How many kinesiotherapy sessions? Here is the number 20. What amount of this Lamanini was prescribed in the doctor recommendations, etc., etc. So that's just a demonstration of what the model can do. Here it's a first application just to extract information. We can imagine that, for example, in hospitals, we could use such a model to process raw texts, raw documents, and put them into a structured way, a structured version. So that's one of our main application exploration. Is to basically to extract some information. Here you can see, for example, that we tried also on some scanned documents, and just with a simple OCR without processing any further the tables or anything, we can get some pretty good results and pretty good extractions on this document with the model. So that's one of the applications we explore, extracting data from documents. Here you can see some fake insurance document too, where we can structure it with the address and the name, etc., etc. And some other application family, and that's the end of the presentation afterwards, is to explore voice, because now we can search information in documents with this question answering technology, and we can extract information from those documents. So here, for example, we tried to extract information from a conversation. Here we can have, for example, a chatbot or a conversation between two humans, for example, for a hiring application. So what are your experiences in the IT domain? What is your background, your educational background? And here, that's also some real reproduction. We can extract, simply by asking a question on the conversation, we can extract some information about the name of the candidate or the sector he worked in, etc., etc., etc. So it can be to structure this conversation. It can also be to search information. So here it's a very large document on electricity laws and regulations. And by asking simply this question, either by text or here with voice, we can build very efficient search engines or very efficient interfaces to augment the information we can have in a very unstructured way. That's it. It was a bit longer than expected. Sorry for that. But if you have questions, we are happy to answer it.
Okay, thanks, Wacim and Martin. So if someone have questions, it's time. Yeah, the first one is the most difficult one.
Yeah. What about questions with multiple answers, like à quel âge et à quelle date est mort Napoléon? So this is a very important research field. I'll just get back to the example here. The model has not been trained on such questions with multiple answers, but of course, to industrialize some applications on, for example, form building based on a conversation or on a document, we will need these multiple choice and multiple answers question. So here, if we try this question, we will have only one answer.
Yes, and to answer to Nicolas, so we have not trained So the multilingual experiments have been carried out only using XLMR because we left mbERT for the work. We have been using XLMR because there was the base in the large version, but would be interesting, yes, would be very interesting to train mbERT on FQuAD and then evaluate it on FQuAD. Would be interesting to see if it beats XLMR.
So next question, when enriching a native French dataset with translated instances, did you somehow notify the model it was dealing with these lower quality examples? No, we didn't tell the model these examples were, if that's the question. We didn't bring the information to the model that this was translated and against a native version. So maybe this could help the model here. If we take this version, the augmented version, maybe it could help getting better results. Our intuition on this low performance, even with almost a double quantity of samples in the training set, is that the translated version doesn't bring any more variety or any more complexity to the dataset, and that with only the 50,000, the 50K samples of FQuAD, we already cover the main language complexities we want to learn.
Yes, and also if I can add something to Pierre de Smet, the thing is the way FQuAD was built in English, it's done. I mean, it introduces an English bias when asking questions that maybe the translation process will not bring French-like, French-specific-like ways of asking questions might not be covered by the translation process, which is also one of the reasons why it might explain the fact that we get lower results. But we have not been digging more into the details. But we are looking forward to, if anyone has better explanations about that, we are looking forward to know more.
On the last question on the human performances between FQuAD and FQuAD, that's the results we show here. So actually the human performance are quite close between FQuAD and FQuAD. So that was kind of a good confirmation of our work and of our data collection. We observed some differences, and we deep dive these differences in the paper if you want to look at it. But basically, we observed, for example, that we gave some a bit more restrictive guidelines to the annotators when annotating FQuAD. So, for example, here we have a 2% drop between the English and the French human performance because, for example, the answers, the distribution of the length of the answers in FQuAD is quite more wide. So we have, in average, longer answers in FQuAD than in FQuAD, and that can explain why this exact match is a bit lower.
Another question from Yves Benigo. Did you include adversarial examples? So for everyone, you must know that this is a data set that is similar to FQuAD1. So it means we don't have I don't know or there is no answer possibility. So FQuAD 2.0 is built to be able to say that a question so that a paragraph does not contain any answer with respect to the question that is asked, and we did not yet annotate samples like that. So we'd be very happy to see further initiatives on the topic, adding that to the dataset, or we will do it in the future. But so no, Yves, we don't cover that yet, but hopefully in the close future we will.
That's works are underway on this adversarial questions.
Yeah.
Okay, thanks. Thanks again, Wacim and Martin.
Thank you.
Thank you very much to all of you.
I'll go for the second talk from Sébastien, which comes from AWS, and here he talks about conversational interfaces. So please welcome Sébastien.
Hey, good evening, everybody. Thank you for being here. Thank you for attending that meetup. I know we all have a long day of work behind us. The weather is beautiful outside, so thank you for being in front of your computer right now. I feel a bit impressed being in the middle of you because you're mostly coming from the data science side of the things. I'm more coming from the development part. So I know how to create a backend, how to create an architecture that scale, how to use conversational services as part of development work, or to call API. But I'm not a data scientist myself. So my talk will be about conversational user interface, but from the point of view of a developer and from the point of view of a user interface designer, because at the end, this technology, as much fascinating I find machine learning and model training and everything Wacim talked about and Martin talked about before, we should not forget that at the end, it's my mom and my dad that are using these technologies, that are talking to voice assistants, that are, it's non-technical people. So the user interface, the user experience angle is quite relevant. Actually, we should keep that in mind when working on these technologies as well. Think about the people that are using that and how we can help them to make their life a bit easier. So over my life, I use many different types of device. I have white hairs, as you can see from the video. So I use the type of PC that you see there on the lower right side of the corner. I see someone smiling on the screen. Yes, no hard drive, just 2 floppy disk. It was in the 80s, and yeah, I have 5 remote control on my table in front of the TV, Wi-Fi actually. I have no idea. Sometimes I need to clean that as well. Is it really the best way to interact with technology? And the answer, if you are here, you know that probably not. What we observe is that like every 10 years, there is a paradigm shift in user interface. In the 70s, it was all text, green or amber. That was roughly the choice that you had. Then in the 80s, switched to graphical user interface with the works at Xerox and the Moz and the Windows. Web arrived in the 90s, mid-90s, mobile in the 2000s, and 2010 and beyond will be about voice user interface. And thanks to the work you are doing, thanks to the work of machine learning, of unlimited data storage, a lot of bandwidth, almost virtually unlimited compute, okay, depending on your budget, we can create super performant systems right now that are equaling or even going beyond the accuracy of human. If you give a lot of power, a lot of storage, a lot of memory, and we can build systems now that have an ASR NLP accuracy above 95%. And that's allowed to put voice interface in actually every single home. And we at Amazon think that voice represents the next major disruption for computing. And we know a bit about that because we built this device, this Amazon Echo device, and with the voice assistants that you probably know, which is Alexa. And when we did so, we kind of create a new category of product that did not exist before. And we saw customers using it at home to turn on the lights, to increase the temperature, but also on the go, on their smartphone, at work. And every single startup right now has some kind of machine learning, ASR, NLP model included into their business plan as well. So how does it work? Customers are talking to their Amazon Echo device. The Echo device is actually just listening for the wake word, Alexa or computer or Amazon. When the device detects the wake word, it starts a beam. So it starts to listen in a very specific direction. It has microphone all over the top, and it listens towards the direction of the customer. It uses the other microphone to do some noise cancellation to process the signal locally before sending it to the cloud. In the cloud, we do the hard things for developer, which is ASR and NLP. So developers do not need to actually be expert in ASR and NLP to add an application to Alexa. I'm probably not going to learn you anything to that group, but ASR is going from the wave file, the sound file, to text, and we go that like everybody else, going through phonemes, and then trying to understand the different words. And we use a lot of machine learning to understand that if we understand 40 times are we talking about 40 times, 40 times for the T, or 40 times for a golf player? We use corpus of text to raise the probability of one phrase versus the other and make estimates based off what we observe in the past and maybe the user preference and the context and stuff like that. When ASR is done, we do the NLP part. So ASR is just producing a text, and from that text, we try to understand what the user meant to Alexa. So when you're speaking to Alexa, you usually have the wake word. I talked about that already. Alexa, ask restaurant finder for breakfast. Ask is the keyword that will ask us to launch a skill and application. Restaurant finder in that case is the name of the skill, the name of the application. And then you ask for something. You want a breakfast, but there are 100 different ways to ask for breakfast. Hey, give me a good breakfast place. Hey, I'm hungry. Find me a place to eat right now or a place to eat in the morning. Find me a spot that serves the most important meal of the day. These are all valid ways to ask for your breakfast. And at the end, it's a single intent. I have one intent as a customer. I want to find a place for having breakfast. And there is 100 ways to represent that. So these 100 ways have to be provided by the developer, and we feed them back into our machine learning model to try to match a text phrase, an utterance, with an intent, what the customer wants to do. So the developer of the application, the developer of the skills, has to provide as many variation utterances, phrases that can express one intent at the end, or NLP models are going to match the utterance that we heard to the intent. But an intent can be a bit more complicated than that. In an intent, you might have parameters as well. In the literature, you usually refer to that as entities. Please recommend me a restaurant within 4 miles. 4, it's an entity here. It's a variable. It might be 4, it might be 7, it might be 9. So you are not going to produce all the variation on the intents. So the recommendation intent in that case has one variable, one parameter, which is a distance parameter and a value. So or NLP will also analyze the phrase to detect the different slots, the different entities, and to resolve these entities into variable with a name and a value. You might have multiple entities inside an intent as well. Tell me about Italian food within 4 miles. In that case, we have a recommendation intent with 2 slot value, to entity, distance 4, and cuisine would be Italian food. So we do all that complexity in the cloud, and at the end we need to fulfill the intent. Once we understood what is the intent, what are the parameters, you as a developer need to provide an endpoint, web services that the service in the cloud can call to fulfill the intent. Can be any type of web services hosted on any platform, from your laptop to any public cloud or your personal or private data center. We don't really care, as long as you have an HTTPS endpoint that can receive JSON and send back JSON. So you're going to do something, you're going to call other API to query your database, you need to fulfill the intent, and you send us just a response. The response is a JSON document, and that response contains the text that we will use to generate the voice of the response, the voice of Alexa, the text-to-speech part, the TTS part. We use SSML, spoken as a markup language. I forgot the acronym of SSML. To add XML annotation inside the text to tell Alexa how to generate the voice of the response. So you can include pause, you can include intonation, you can include small interjections. For example, if you want a speech synthesis markup language. Thank you, my slide. I know I can always count on my slide when I forgot something. Speech synthesis markup language, which is standard. It's not specific to Amazon. So you can include these small HTML elements inside your answer, like a break time for a pause, for example. Or if you want Alexa to spell out a word, H-E-L-L-O, instead of saying hello, you can say as, interpret as, spell out. And we have a very long list of SSML tags that you can use to give hints about how Alexa should answer, including interjections, like small phrases that are pre-recorded instead of being generated, like hooray, c'est la vie, and we have a long list of phrases like that. So that's a quick recap maybe for you about how Alexa is working or how personal assistants in general are working. And many customers are telling us, hey, we want to have the same brain inside our app because it's great to develop an app for Alexa, but the app for Alexa can only work on Echo device and device that have Alexa included. I want to have something private for my customer inside my website, inside my mobile web app, or inside my device, which is not an Alexa skill, where there is not the entire Alexa ecosystem there. And for that reason, we released a service called Amazon Lex. And Amazon Lex, it's a conversational engine living in the cloud. So you have absolutely nothing to manage or to configure or to install. That allows you to create a conversational interface inside your application, mobile application, web application. Behind the scene, it's the same technology as the one I just described. It's the Alexa technology that allows you to create conversational chatbots. These chatbots can be in text or can be in voice. They can run from any of your application. And the service is designed for developers. So you do not need to be data scientist, an expert in ASR, an expert in NLP, any developer that can understand the concept of intent, utterances, that can develop an endpoint, web services that receive and send JSON and send back SSML, can actually create a conversational experience for their customer inside your application. So an Alexa skill, it really lives only on Echo device and third-party device where Alexa is there. It's distributed to the skill store, while a Lex chatbot can work on any device or any application that you are building. So it's really your responsibility to distribute the bot, to build the device, or to build an application where the bot is actually available for your customer, and it will be available only to your customer, where an Alexa skill is available to all Alexa customer. Everybody that has an Amazon Echo can actually use the skill. So that's the main difference between Amazon Alexa and Amazon Lex. So with Lex, you are going to find the concept of intent, utterance, slot, and the fulfillment, just like with Alexa. The intent is what I want to do as a customer. The utterance is how I want to do it, how I want to say it. The slots are the variable, the parameter inside my utterance, and the fulfillment is the backend service, the web service that Lex will call to fulfill the intent. So for example, if I want to book an hotel, I will say, hey, I would like to book an hotel, and the system needs to need a bit more, which it is, the start date, the type of room. So these are the slots, and then once all the slots are resolved, we are going to call your backend service, your web services, to fulfill the data. So what you, as a developer, needs to think in terms of designing a conversation. First, it's your intent, your utterance, your slot. A customer will probably not give you all the slot in one utterance, like I would like to book an hotel night for tomorrow in New York City for 10 nights. Nobody will think like that. That's too much information for a human person to carry in one single phrase. And remember also, the longer is the phrase, the lower the accuracy is in terms of ASR and NLP. So it's pretty sure we're going to miss one thing there. So most customers will say, I would like to book an hotel. And then the system will need to identify, okay, how many slots are required to fulfill that intent, the city, the check-in date, the duration, and the type of room. And the system will collect the slots one by one. So we have a system called Dialog management that will ask question, follow-up question, and make a multi-turn conversation to collect the missing slots until the system has all the slots, all the value, and then it will call your fulfillment function, your fulfillment web services. And all that can be configured quite easily in a management console that I will show you if I have a bit of time left at the end. You can also customize the conversation based on customer preference. So for example, if you know that it's me and not someone else talking to the bot, we can invoke a web service on your side to customize the dialogue. So for example, I would like to book an hotel. Oh, would you like to prefer to stay downtown this time as well, just like you did last time? Because the system can detect that Mr. Sebastian went to that specific hotel downtown last time. So at every step in the dialogue, there is a callback or an optional callback to a backend function on your side that allows you to customize the next question and to make the customer feel that actually the system knows the customer and as memory, as context, which is one of the most difficult things to do in terms of a voice user interface, is to pretend the system knows the person talking to it, just like a human would do. A human would remember the conversation from 2 weeks ago. Programming a system to do so, it's much more complicated. Also, be sure to handle error correctly. If you did not understand something, if the slot value does not exist, for example, a city name that does not exist, be sure to rephrase the question, to ask the customer to repeat, but after 2 or 3 times to plan for an exit. There is nothing more frustrating as a customer to say, hey, can I order a pizza? Oh, I didn't understand what you want to do. Can you repeat? I want a pizza. Oh, I didn't understand. Can you repeat? And then you enter in the equivalent of an infinite loop in programming, but in a user conversation, which is extremely frustrating for the customer as well. So be sure to plan for exits in your dialogue after a couple of recovery strategy. Also think that device have more than one mode. Hearing the voice and talking is great. It's probably the first way we learn to communicate since we are baby. But most of these systems are living on screens, desktop, mobile, connected assistants or whatever, and sometimes providing additional information in the terms of text, of picture, it's a welcome add-on to the conversation. Instead of having a long phrase saying, hey, you can choose between 3 cars in that example. The first one is a compact, blah, blah, color red and blah, blah. If you give all that information by voice, it will be too much payload for a normal human brain. After the first or the second one, usually people will either disconnect or will forget what you said at the beginning. So providing additional information as picture and text on the screen when it's available allows for better cognitive load management from the customer side. The fulfillment part, I talked about that already. It can be pretty much anything that is a web services, or if you are using the AWS cloud, a Lambda function. So a Lambda function, it's a serverless code. You just give us the code and we run the server for you behind the scenes, so you don't have to care about that. If you are designing a conversational user interface, please start with the people. At the end, it's people that are going to use a conversational user interface. Continue to think in terms of user experience. This picture was taken during one of the research sessions from the prototyping group at the BBC. BBC has more than 100 persons working on voice conversation today, not only on Alexa, on all platforms, their own platform, Google and Microsoft and many others. And in that session, they were trying to find a dialogue flow for podcast and what is the best way to ask for a podcast or to resume a conversation, to continue to listen to your favorite podcast, and how to grab which podcast. Of course, you cannot browse a huge list when it's a voice user interface only. You don't have a screen most of the time. So how can you design a conversation that helps the customer to go very quickly to the thing they want to do? In that case, it was listening to a podcast episode. And they do that as role play. So the person on the left with the blue hat on was playing the role of Alexa, and she was replying to the questions of the other people. You saw a lot of post-it on the table. That's also a way to identify all the utterances and group them by intent. That's a way to design and to discover intent and utterance during your design process. What we learn from our customer in terms of user experience is these 10 tips for great conversational user interface. The first one is not like me, is to be brief. When a voice system is talking to a customer, don't overload the customer with extra information. A prompt of 6 to 8 seconds is typically where the customer will drop after that. So do not talk for more than 6 or or 8 seconds. Stay natural in the way of talking. Don't use the same vocabulary as you would do if you were talking in front of the customer. If you don't hear an answer, if the system cannot get an answer, re-engage the conversation. I didn't understand what you said. Please, can you repeat? And offer multiple choice. There is nothing worse than voice system that's starting, hey, good morning, what can I do for you? I have no idea. If you don't tell me, there is no menu, there is no icon on the screen like a graphical user interface. So, hey, welcome to the food ordering application. I can help you to order food, to check your previous order, or to give you nutritional advice. What do you want to do? And if you phrase the question like that by proposing option A, option B, option C, you will drive the customer to answer option A, B, C, and drive the conversation in the way you want, and not in any possible way that the customer can talk to your skill. Be current in the option, in the order of the option, in the vocabulary that you are using. Teach customer. They don't know how to use a skill. They don't know how to use a voice application. So at any time you can propose some help. You can propose longer help the first time the customer is using the application, shorter help if it is a returning customer, or maybe no help at all if it is a customer using your skill regularly. But provide some guidance to your customer. And like I said before, plan for escape. So if you don't understand something, if the system does not understand something, you as a programmer should avoid entering into an infinite loop to ask the customer to come back with more details. And you should plan for an escape route at some point. 8 is something I observe a lot for French, for Spanish, for Italian, for German, for all these languages where there is a gender. We make a difference between masculine and feminine, unlike in English. But for example, in French, dites-moi quand vous êtes prêt. N'est pas une bonne phrase. It's not a good phrase because prêt, it's you assume that the person talking to you is a male, and you should find a way to phrase either to know your customer, know it's a female talking to you, and then dites-moi quand vous êtes prête, or phrase your phrase in a sense which is gender neutral, where you do not assume that the person talking to you is a male or a female. And more even than with traditional graphical user interface, pay attention to every single details, punctuation, accents, rhythm, vocabulary is super important, and test. So that was my 10 tips for great conversational user interface. If you want to try that on Amazon Lex, here's a $25 credits for you. You just scan that QR code, or you go to ratings.goaws.com with code 186, or you just scan the QR code, and you will receive a very, very short evaluation form with 5 stars. And then on the next screen, you have a code that you can redeem on your AWS account to try that, to try Amazon Lex, to try AWS Lambda for your graphical user, for your voice user interface. That code will only be valid, that QR code will only be valid for the next 10 minutes. So you can do that now. And the slides that I presented are on my Twitter account. Very briefly, my Twitter account is Sebsto, S-E-B-S-T-O. They should be posted around 8 p.m. Paris time. So right now, 3 minutes ago, they should have been posted, so that you can find the slides over there. I leave that back on that screen, so you have 10 minutes to collect the service credit that you can redeem in the console, and I'm happy to answer any question you might have in the chat. Or by voice, you can also unmute and ask a question in French or in English.
Okay, so do someone have a question for Sébastien, the conversational interfaces? so no questions. I think it was very clear and
Very
maybe
boring.
a bit tired.
Yeah, it's the
So thanks, Sebastian, for your talk.
Thank you. Thank you for having me tonight.
And thanks again to the to our free speakers for tonight's meetup. And so this is the end of the meetup. And as usual, we make so the slides of these two presentations available on our website, and we'll communicate about this. And so thanks everyone for being here tonight, and hope to see you next time for the next meetup in September. Thanks very much.
Bye-bye.
Bye-bye.